Welcome back to our reimagining content layer stream. Um, so I did do a couple of things like off stream since the last time that we met. I think the last time that we were chatting, we were talking about like the document type and adding computed fields, and we had like a desired API, but while we were on stream, couldn't quite figure out the types. So off stream, I figured out like a nice way to kind of get the desired API we were looking for, I think. And I ended up using a technique called reverse map types to do it. So we can take a look at that. I also implemented some of the methods that were kind of just stubs, just because I was there already, cleaned up some of the types a little bit. So we'll walk through kind of all of that code. And I also separated out the document source type into its own file, just so that we could start to get a little bit more of like the structure of like the module that we're building up here. So let me try and share my screen. So I was telling Mike before we started the stream, I'm gonna attempt to use my new NeoVim configs for this, and if it starts to become cumbersome since I'm not used to all my key bindings yet, um, then I'll swap back to VS Code. But don't at me for using VS Code.
If Dylan is on the call, he would enjoy it very much. Let's put
Uh,
it this
the
way.
th the thing is I stole a lot of Dylan's key bindings.
So it's
So
his fault if you can't be productive.
that's right, it's his fault.
Okay, that's
Let me share. So yeah, let me, I guess, start from the top here. So um, we have two files in our file system now. We've got the document file, which was previously our just like our plain index file. And now we have a source file, and the source file is literally just like the stuff from the document source. We can take a look at it. I guess we can take a look at it now. Um, this is literally just the stuff that was in the document source type before. I added a few type helpers just to make like extracting, for example, like the meta from the document a little bit easier. Um, but basically, all of this is pretty similar to what we had before for the document source.
shouldn't we make this a union, by the way? Union of stuff instead of a interface. I'm not sure.
Where?
Like
Sorry.
at the moment we only have a single source, which is the file system source,
Right.
but at some point we might have different sources. Shouldn't our source be a union of supported sources, or do you envision some kind of standard API that a source would expose so that you can make custom
We can.
sources? It's rather, is it a closed union or an
Yeah, I
open one?
think that it's. I'm not exactly sure what the like desired API for the source is going to look like yet. Um, I think the reason why I chose an interface for now was so that um if we wanted to have like external packages provide different types of like source plugins, I feel like it potentially could be easier to do it via an interface. Because then you don't have to add to like the union exposed by the module. But we can talk about this more. For now, like really all we need the source for is basically to expose the meta. So like it's pretty easy to swap this to a union if we decide that that's more of like what we're looking for. Um, but we can come back to this. Like I think it's going to become relevant shortly, but for now, I kind of want to talk about uh, like the document type, if that's cool, and then we can always revisit the source. Like once we have to start like implementing the actual functionality of it, if that works.
Yeah, absolutely.
Cool. So yeah, our document, I've added like just a couple of comments to help things make sense for ourselves. So similar to previous, our document has a name, a description, the source, and the fields. Um, and then I've also added this computed fields property to the document. And I think the computed fields are um, The reason why the type looks like this, why we have kind of an array of arrays of computed fields, is because I thought this would make it really easy, once the documents have actually been imported into the, like, engine we're gonna build for Contentlayer, we can really easily, with this data structure, kind of provide, the kind of desired API that we had in mind when we chatted last time. So just to refresh everyone's memory, the idea was that when you're adding computed fields to a document, um, if you have multiple computed fields that you want to resolve concurrently, um, that don't depend on like each other, right? That like you don't need like a previously computed field to resolve the current computed field. The desired API would be to like basically call add computed fields and pass in all the fields that you want. So that would create kind of a group of computed fields, and the fields within that group can be resolved concurrently. But we also wanted to have the ability to specify like multiple groups of computed fields for a document where the subsequent groups could rely on the previous group's computed fields to basically implement their own functionality. So you could imagine like, I don't know, a document has a title, like kind of like the one we have at the bottom here, our post, right? So this is kind of our example API. Our post has a title. And then we want to use the title to compute a slug. And then maybe we'd also want to have another computed fields here where, I don't know, we have a better slug. Um, when resolving the better slug, we might want to have access to the previous slug in the fields of the resolver, right? So the idea here is that once you've got a group of computed fields that you've added, whoops, to a document, the um, subsequent computed fields that you add now have access to the previous group of computed fields. So, you know, you can keep adding properties here, and then in subsequent computed fields, you'd have in the fields property access to the previously computed fields. Um, so
And the array of arrays, basically, the first array is going to be processed sequentially, while the inner array is going to be processed in parallel, I guess.
yeah, so basically I just to keep us like our thought process and on track, I sort of like sketched out. I mean, these comments might not be super clear yet, but the each sub array within the parent array of computed fields is a group, right? And these groups are processed sequentially. They're resolved in a sequential manner, but the fields within each group can be resolved concurrently. And the first argument to a group's field the first argument to a group's field resolver will be the prior group's computed fields joined with the document fields, meaning that like when you have a compute like we showed before, the resolver gets access to all the previously computed fields as well as the documents fields. And then the second argument is the metadata provided by the document source. Um, and yeah, so that's kind of like why I chose this like very simple data structure. It allows us to easily, like in the engine, iterate through the parent array in a sequential manner and then resolve the subarrays computed fields in a concurrent fashion.
Which,
Uh,
by the way, is extremely similar to what we do, for example, with the internal structure of request resolvers,
mhm.
that we could batch over multiple requests, and we could also have some requests that have to happen sequentially. The inner data structure is exactly the same. We have these two nested arrays to to isolate the things that have to happen sequentially from the things that can happen in parallel. That's nice.
Yep. Yeah, so I figured we can go with this and just sort of see how it works out. If it ends up like that we need to change something, whatever, we'll figure it out then. But um, this seemed like the right choice for now. Um, so now we can talk about a little bit of like what I did to implement this, and maybe Mike can roast my TypeScript foo here. But uh, I tried to I in thinking about how to implement add computed fields. Um, I realized that we really only need access to the schema type for the resolver when we're like trying to figure out the types, right? Because the schema type, I mean, for a computed field, the schema type for a computed field dictates like what the return type of the resolver is going to be. So using that information, um, we can basically figure out what the structure of the computed fields should be. So let me maybe like walk you through this type really quick and we can talk about it. So add computed fields takes in this generic, right? And again, I'm using a technique called reverse map types. I think Matouche, I think, uh, has done a lot of like advocacy for reverse map types, if I'm not mistaken. Maybe I'm
Yeah, I
making,
think the fact that this works is actually thanks to him.
yeah. So
For the sake of who doesn't know Mateusz, his username on Twitter is Underist, and he's a very active contributor of TypeScript, and uh,
also a just very
and he's
nice,
also helping us in in some of the most tedious TypeScript issues we had.
yeah, just
Great,
a
great, great person.
very nice, like, like, such a nice human and, like, very patient. Also helped me, with implementing some of the basic functionality for the Effect Playground, when we were first starting to work on it, so shout out to Matoush. Um, but essentially here in this generic, we're saying that we have a bunch of computed field schemas, right? So not computed fields, but this is actually extending a record of string and any schema, which is kind of strange if you think about it, because the idea is that we're taking in an object of computed fields, but really the only information that we need in the generic is actually the schema, and then we can derive using the technique of reverse map types. We can derive the rest of the information about the computed field from the schema. So in the generic here, we're taking in a record of string to schema, where the string is going to be the name of the computed field, and the schema is going to be like the resolver schema type. And then I implemented this kind of has duplicate keys type to uh, basically check to make sure that the computed fields that we're passing in does not have any fields that will conflict with the fields that already exist in the document. And since we're always merging the computed fields into the fields, like you're
Okay,
building up
by the
this.
way, Dylan is rating us with 75 people, so we're gonna have quite a crowd here.
Oh, great. Thanks for the raid, Dylan. So with this like has duplicate keys type, we get the benefit of using TypeScript to help us prevent field collisions at the type level. So I'll show like how that works in a second. But the has duplicate keys type is pretty simple. And again, like Mike, feel free to roast my TypeScript at any point in time. But basically, just checking if the keys of the T type here intersect the keys of U, and if they do, I'm returning true. If they don't, I return false. And then in our fields here, if has duplicate keys extends true, we return this kind of like pseudo error type thingy, um, which again, I'll show how that works in a second.
But
But if we,
that error will not be on the key though.
it actually does work. So sorry, hang on. Let me just, let me actually do this. So you see that we actually, oh, by the way, I'm using Dylan's extension for pretty types in NeoVim or pretty TypeScript error translations in NeoVim. But we actually do get the error on the key here, which is nice. And
Uh, no, we don't. It says you can't assign an object with a slug property to, can't pass property slug to an array of. That's not on the key. So if you have multiple keys, it's gonna show all.
see. Ah, you're right.
Actually doesn't even show an error.
Interesting. See?
This
Michael
is not any better than what we had last time.
alright, well, Mike already roasting my TypeScript, foo here, but we can figure out the, duplicate key check in a minute. But I wanna show at least how we're computing the computed field type. Um, so basically just, creating a map type um, over the keys of this record, and then, passing so in the computed field type, which is down here, we take in the fields, the resolver schema, and the source meta, in order to actually build up our computed field. And so if we look here, we're just passing in the fields of the document as the previous fields for the computed field. This will eventually get passed to the resolver, which is why we have access to it. Here, we just index our record to extract out the schema, and then we also just grab the source meta from the document source, which is being passed in here. So what's nice here is even though our duplicate key check might need a tiny bit of work, which I'm sure Mike can help us with, the nice thing is that if I just call this foo, the nice thing is that now our fields do indeed get access to the previous computed fields as well as the documents fields. And we can enforce the return type of our resolver based on the schema that's coming in. So if I change this to, for example, a number, and um, we see that we can basically use that schema to enforce the return type. So I think, I mean, feel free to roast me on this, but I'm pretty sure I at least solved the problem of like the computed field itself, but we just need to figure out the duplicate key check.
Well, not to roast you because I don't want to be a roasting.
I'm asking you to roast
I,
me.
I think it has to be rewritten from scratch because it's not gonna work. Not in
Okay.
that, not with a reverse map type.
All right. Why not?
Has to be an intersection.
Okay.
But I am cloning the repository, so we'll see if you can roast me on that shortly.
Um,
That will be fun.
while Mike is doing this, the only other thing I added in terms of like type helpers is I just added this like type helper that merges fields with computed fields. Um, So this way, in the return type of our document, we can merge the field schemas or the fields themselves with the computed fields easily in a little bit of an easier way. Um, and then what else did I add? So, like I said, I kind of tried to sketch out some of the stubs for that we had previously, where we weren't really implementing anything; we were just doing everything at the type level before. Um, So I added this like make internal constructor, which essentially just uses the prototype here that we've created for our document, creates an object with that prototype, and then assigns all the fields that we want to that object. Um, and the reason why I have like a separate constructor here is because we can use it both in the add computed fields on our prototype, as well as in the make constructor for our document. Because as we've shown before, like the make constructor can't take in computed fields. We need to add it as a separate method. Um, yeah, I think that's pretty much all I added since the last time we spoke. Yeah. So just checking if there was anything else so that everybody's like on the same page as us. I think that was it. Um,
Yeah, there hasn't been many changes. I was checking the commits. Seems like that was it. I mean, there's a wrong commit message that says fix up types for add computed fields, but yeah.
whatever. Um, so yeah, I don't know.
Now the funny thing is I'm roasting you, but it's highly probable that I can also don't I can't do that too, so this is
Yeah, I
gonna
mean,
be fun.
I don't know if you want me to, or if you want to take ownership of the screen for a moment and see if we can figure out the duplicate key check. Um, but yeah, I feel like at least for the computed field itself, this is working nicely. And if we look at like our mock document here that we're building up, um, we do get like kind of the nice signature that we were looking for, where we can see the fields of the document that'll be present when we actually like put it through the engine, as well as the source that this document's going to use. Um, so at least like we're almost there on a type level. Um, yeah,
Okay.
I don't think we had any other like from what I remember discussing last time. I don't think we had any other goals on the type level for the document. Um, yeah,
Okay, let me try to take over the screen then. Now, Dylan, note that we've just switched to a proper IDE, not that thing that Maxwell has. So, what's the idea here? Okay. Uh, merge computed fields. Let's start with removing everything, which sounds like a good thing. Compute it.
taking
Um,
taking all my hard work, throwing it out the window.
no, no, that was not the. I probably read it bit by bit. But the issue is, if I don't start progressively, I'm also lacking uh, understanding of the dynamics. So first of all, what's the shape that we have to respect? So we have to have a record of string. Are we allowing only string keys in
I think
general?
I think it's probably reasonable, at least to start
Okay.
with. I mean, we could use property like a property key, but I feel like if we're saying that this is going to be coming from like markdown files and other things, it probably just makes more
Yeah,
sense to the string.
yeah, that's true. And what's the shape of the thing that we have to respect? I guess it's the same shape of these structured fields. Is it this?
Well, it depends on what you're saying. Like if we're saying that the shape of the computed field, then it's really a description, a schema, and a resolve function. Um,
Do we have a type already for this?
yeah, there's a computed field and then there's an any computed field.
Okay, that's the any computed field, but I should also have, uh, I mean, I should specify the type to have the fields inferred. So I don't think I can use the any computed field, because if I use the any computed field, I will lose the inference on the generics.
Probably, yeah.
So I have to at least specify.
There's yeah, if you want the computed field itself, then you can use document.computed field and we can fill in the generics.
Okay, so that's document.computed field and field source matter. Where are we getting source matter?
So fields, if we look at the computed field type for a moment, the fields are like the existing fields on the document, like the things that get passed as the first argument to the resolver. So you can
So
actually,
first of all, we have the fields.
yeah,
This is
fields.
the first.
The second
Then,
argument, the resolver schema, which is a property that's on the computed field. So for now, you might just want to put any for there. And then the third argument is the source meta. So you can actually do source.source.meta, or and then yep, and then pass in the source on the document. Literally just source again. Yep.
okay. Oh, that's the thing. Are we getting okay? There's no
So
slug here because I'm not returning the merged fields yet, which
right.
is fine. But point being is here I do have the fields. Now, basically my only objective here is I want to get an error if I have a property which is also in the okay.
Yeah, I think that's the first objective. The first objective is to get an error if you have a property that exists, if you're specifying a property that already exists in fields. Yeah, you could even probably call it like exclude duplicate field or something like that, or exclude duplicate property, whatever. Doesn't matter. Um this is the first like this is the first goal.
Okay. So here the first thing is to map over the keys of computed, and this is the good case. In this case, I'm still getting everything, and it's fine. Now here I can say, does k extend key of fields? If so, I have otherwise.
This reminds me of like all the commit messages when we were hacking on all the fiber runtime reworks. It's just like fix, fix, test, fix, fix.
Fix, test, fix. Okay, why is this not?
I think that the problem here in the first computed fields, you'd need to put title or something that exists on the document. Because in the second computed fields, we're not merging them yet. So it doesn't care that slug is there twice. I
Ah,
think,
yeah, that is true.
yeah, so put
That
like,
is indeed true.
if you could put
Title. So I can
title.
call this title. Eh,
And we can probably even make the error message nicer than the one that I had now, because we can, I, th- I don't know if this is allowed in TypeScript, but we might be able to do,
But
uh,
first of all, I want to see if this works over multiple properties, because this was the initial. Yeah, you see, we still get an error here, which is positive.
yeah, that's nice. And then what is the
But
second
before I
property I
do
have on the document? Because we could also probably see if we get two errors if we specify another duplicate property. Would that work? Or would it only error on the first?
author. No, it should, yeah,
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 very nice.
errors on both.
Really nice.
The expected type comes from the property order, which is declared on type. So now we can do something better. I can say that property k fields and string property k already exists. Now you're gonna improve the error messages, of course, but where do I get this? Property title already exists.
Very nice.
Wonder if there is a better place that I can show this error, because this type is a bit awful. Mm, I do. This is gonna be an error. This doesn't. So if I show it on the property, I'm gonna see that this object type is not assignable.
Yeah. And I already think this is pretty nice that you get, like, a very scoped down error message, but obviously if we can make it better.
Yeah, I guess these on the description though it's not.
No, I think having the error right on the key is nice, even though the, like, TypeScript error message might be a little bit, it's, like, not ideal, like, the verbosity, but having it right on the key is definitely what we want.
Okay, then let's go for this. And now we just have to merge this stuff. So let's say that here I have a slack, and here let me just copy it. So the second one should error. What's the shape of the fields? Yeah, it's a bare bone generic. The shape of the fields is just the resolved thing. So I should take the key and the type of the schema, I guess.
Yes.
Yes.
Yeah, because when we merge the fields, it really is just like the yeah, exactly, the name and then the schema.
And here I want to get schema.schema.type of computed k over the schema. And I want this prettified. Schema dot. Uh, how was it to pretty
Oh god. Uh,
simplify? Yes, there we go. Okay, this error is exactly in the right place. Plus, this type seems to be fine, except I have to add a read only.
yeah, this is nice. And I think, Mike, I have a, type helper called merge computed field.
Yeah, but that was
Oh, that was, yeah, that was taking the, yeah, yeah,
I think I have to kind of erase
all my beautiful hard work.
all your beautiful hard work.
So there is one additional thing that we wanna solve here. Um,
What?
so if you scroll down to the document, my approach also gave a type error if you return a value from the resolver that doesn't match the schema.
So here I should like
Yeah,
return
try
like
returning a
100.
number.
How do I get this to work and why this doesn't work, first of all? So the reason that this doesn't work is quite simple. It's because there's no link between the resolve function, the schema, type of resolve schema. Why is this not erroring? How did you make it error?
I was able to, because I was using the reverse map type, I had the schema type in the generic, so I just used the schema, like, from the generic. I think right now we're passing any in the computed field, like, in the construct in the, add whatchamacallit, in the generic of add computed fields. Right now we have a computed field of any, but it should, um and I think that might be the problem, but it should give us the schema in the generic, right?
Let me just do something horrendous. So this any is
It's basically computed K schema.
it the schema type or is it
It
the
it's the schema type.
okay, so I should not.
Yeah, the only nice thing that, that was the only nice thing with the approach that I was using is that the error happened, like, on the return type instead of on the resolved property, but that's not a huge deal, I don't think.
In the exclude duplicate, I
Yep.
can add another condition just straight here.
I say that the chat says that you take pleasure in deleting my code.
Yes, I take a lot of pleasure in deleting your code. Let me show the message. Yes, yes. I take pleasure generally in deleting code. Every good developer takes
Mm,
pleasure in deleting code.
that's fair. That is fair.
Mhm. Okay, that might be too hard to do in a single.
And this isn't bad, like, we still have the error on the resolve function, it's just that, um, it was nice having, like, the way that I wrote the type before, the error type was basically it was exactly that, it was just happening on the return type, but I think that's still a pretty nice error to get.
Okay, it has to happen on the return type.
Doesn't have to, we still get the nicely scoped down error. Like, I don't think this is an issue, it's just more of like a if we're really shooting for, like, the best DX ever, like, in an ideal world, that would be what we see.
I mean, it doesn't hurt to try.
Yeah, why not?
How did I get the source meta?
Just,
I have it.
it's source.source.meta source.
Source.source.meta source. And here it's computed K schema. I mean, this is probably on the return type. It's just that you have
It's definitely on the return type, it's just that when what I was saying before is that the squigglies were occurring on the the diagnostic message was occurring on the return type.
the
Uh,
red squiggle.
the red
But
squiggles.
I wonder why.
Yeah, I don't know. Let me actually verify that on my side before I, like, keep having you go down this path. I'm pretty sure it was correct, but yeah, I got, what does the LSP say? Type effect number never never is not assignable to effect string never never with yeah. So for me, uh, the
Yeah,
dot
which is exactly what I get at the last.
Yeah, but the squigglies occur on the return type. It's not like the I think the what I'm saying is the LSP gives us more scoped down message. Like if you hover resolve again,
I wonder if this is true in VS Code. Actually, fix
yeah, maybe
the.
it's the NeoVim LSP. Although it does use TS server, so
But maybe your extension for nice errors. Let me push this first, then
go
I'll
for it.
roll back.
I wonder if there's a way to combine your extend duplicate check with my reverse map types.
Probably.
I'm actually gonna do that while you do this.
So you say basically here I say 100. Yes, this is
See?
odd.
You see how much like shorter and nicer the type ends up being? It's weird. I wonder if we can use the logic that you wrote for extend duplicates with my logic for using the reverse map type and still get the benefit of both.
Possible, but now I will stop sharing so you can restart.
Before I pull down the changes, um, I wonder if there's a way that we can essentially do what you were doing with exclude duplicates. I want to try something. So you did in key of, oops, key of computed field schemas. Uh, and then you did key of, wait,
No, I
name,
basically name extends key of fields, which means it's already present in the key.
right. Whoa.
You don't need the array.
Okay, I'm sorry. Hang on. Dylan, help me.
That's what happens when you don't use a proper ID.
Error. I'm just gonna put error for now.
You gotta use a template literal otherwise.
Okay.
This is going on YouTube. I'm gonna be roasted. I know.
Um, okay, here, name extends
Let me go take
this,
something to drink. Actually,
and then if we're okay, we do computed field object fields, computed field schemas name, and source meta. Computed field schema's name does not satisfy constraint any.
yeah, I think you need to use a base type on the computed field schema because this is a bare bone generic.
Mm, okay.
So like the extends record.
And then here. Wow, I got that keybind right. Wow. Okay, let's go. So this will be computed field schemas, fields, and source.meta source. Hey. Okay, so we still get this error here, which is nice.
Max, do you know what was invented in 1963?
That was invented in 1963, Mike.
A mouse.
Okay,
Was invented by Doug Engelbart. Interesting.
so I feel like we're getting, oops, I think we're getting what we want here. We simplify this. Okay, so we are getting error, which is good. Um, and if I take this away, oops.
Well, say title 2, because you have
Oh
to
yeah,
trigger the other.
I need to ask. I need to figure out how I can prevent commas from triggering LSP completion in Vim. Title two. Yeah, this is good.
So Sandra is saying that a real programmer only uses a keyword. I guess you old folks don't use effect, even I'm not a real programmer.
All right, and if I may turn a number here, does this work? If I change this back to slug? Yes.
On the return type?
Yeah. Look at my red squigglies. Right?
Nice.
If I get rid of all
I
these red.
wonder I wonder how you did it, because I was searching for who created the mouse and everything else, but
I basically literally searching just to roast me. I used
okay.
exclude duplicates, and I basically made exclude duplicates do the same thing that you did before with the name extend string, return an error, blah blah blah. And then I just did what I was doing before with the reverse.
Oh, I got it. You no longer have basically a the naked generic computed field schemas. You're probably gonna lose that, but we don't quite care that
Mhm.
we lose that, because we only need the computed fields. Okay, I guess that works.
And what's nice here is if
And
we want
without the intersection, the errors are much cleaner, because basically it's like you have a basic type, and you can't assign to the basic type, instead of the intersection doesn't assign between themselves.
right.
Get?
Oh, I'm glad we figured this out. That's nice. It's clean. Let's get rid of all this. Let's get rid of this. Uh,
That was an interesting challenge, yeah.
wait. I
And maybe make the error nicer, like use a
Yeah,
template
I'm
leader
really
or
I'm really scared if I open a template literal again, it's gonna blow up TS server. So we could try. Or I can just do
mm,
try er, ah,
really.
I'll have to figure out why that's happening, but for now I'll just leave error here. Um
Please write error. I'm not using a proper IDE, so I can't. Hey, what else? Okay, fine.
um okay, so I feel like we have a pretty good user experience here now. The types are I feel like the error messages are super clean, for this situation. And then if we go back to fields, to fields dot title dot slice. Again, this is not how you make a slug, but whatever. Um, and let's just confirm that all of our previous functionality works. So we still get this I hate my mouse error, which is good. And if we make this slug2 and we check out the fields and we adjust this to like a number. So this resolves now, and fields includes our slug.
And by the way, just check that we still get an error for multiple keys. So if we have multiple keys in the same place.
You mean like if we have multiple keys and it check for the duplicate collision?
Yes, exactly.
Yeah, it looks like we still do.
Okay, good. Then it's fine.
Excellent. This is great. Whoops. Cool. And now at the very end, when we look at our post type, yep, we get exactly what we wanted. The fields, the source. Yeah, this is perfect.
Yeah, we're getting everything. That's nice.
All right. So I will push these changes in a second. Um, just looking to make sure we didn't aren't left with any like types that we're not using. Okay. Um, cool. So I will resolve the commits in a second and push this up, or I can just force push it and overwrite all your work. um, the
So taking pleasure in deleting code is reciprocal, I see.
It is reciprocal. It's very reciprocal. Um, but
By
before
the
I
way,
do,
I start to wonder, now we are taking care of generating proper types, nice, and everything else, but how are we gonna generate those types for the
yeah, I
output?
actually had a proof of concept that I had wrote a while ago that iterates through a schema, and this actually was based on some code that Julio wrote.
Yeah, basically a TypeScript compiler for schema.
Yeah, he had written a TypeScript compiler a while back in the tests for schema, but removed it because maintaining it was a little bit of a pain in the neck, which makes perfect sense. Um, but I had taken that and sort of like adapted it to this particular use case a while back, where basically once the document's like fully resolved and we're left with the like fields and their schemas and everything like that, we don't even need the document to be fully resolved. We can generate the types independent of resolving the document because we have all their schemas. Um, you can basically just use the schema to generate the TypeScript type by iterating through the schema AST. Uh, and
But
sort
I
of
wonder, can't we just use the type given that it's all TypeScript?
I
Like,
mean,
can't we import type into, might be odd.
um, yeah, I don't know. What is the
Because let's say I make, for example, I'm author instead of being a schema struct is a class. I'm not gonna have the same instance of the same class if you generate a TypeScript file.
right?
So I wonder if we can actually import those document definitions in the final app. That's a different strategy from content layer, of course.
Yeah, it's something to think about for sure. I'm not 100% sure. It's an interesting strategy, but I'm not sure. Um, hmm. Yeah, it's something to consider for when we start, like, figuring out what the, like, actual output is gonna look like and how that might deviate from the existing. But I am very happy with at least the UX for defining documents now. This is really nice. And just to remind everyone the reason why you might have two separate add computed fields here. The idea is that like within a single add computed fields, all of the field definitions that you might have here. So if we have like slug three, slug two, or maybe we make this slug three, this slug two. The idea here is that these fields here in the first add in every add computed fields that you do, the fields can't depend on one another, right? So slug can't depend on slug. Slug 2 can't depend on slug in this case, but those fields can be processed concurrently. So the resolvers for those fields we can process concurrently. Um, and then if you do need access to a previously computed field, you would just call add computed fields again, and you would have access to all the previously computed fields in this type because every group of computed fields is processed sequentially. So every call to add computed fields you can sort of think about as being processed sequentially, while the inner fields, the resolvers for those inner fields are processed concurrently. Um,
And I mean, we could even add an option to take a concurrency. I mean, this is at some point this is gonna be over engineering it, but if we think in terms of like two subsequent add computed fields calls are akin to an effect of flat map, uh, we could make the multiple keys to be akin to an effect dot all, and at that point we could quite literally also pass the concurrency to say, look, I want this concurrent, I want this sequential, and blah blah.
right.
Not matters in any way. Again, I think this is at some point over engineering.
Well, if you're up for it, Mike, I'm happy to go for a little while longer. I don't
Yeah,
know,
sure.
but maybe we can take like a 5-minute break and then we can start maybe digging into some actual like we can pick a place to start on the actual like engine and start thinking about it. I feel like there's a lot of different places we could start. We could look at like how one would maybe we would effectify compiling the content layer config. We could, take a look at how documents might be processed. So maybe we can take a 5-minute break and then start digging into some of that.
Let's do that.
All right. Um, Yeah, so I thought maybe I mean, there's multiple different things we could potentially tackle as like a next, I don't know, step. Um, I think when we were talking about like the features of content layer uh, we like the fact that the config is a TypeScript file, right? That you can basically use to write TypeScript, and then your documents basically just get exported from that TypeScript file. Um, So maybe we can start thinking about the configuration file and how that gets loaded into the engine. That's one potential like way we could start digging into some actual code. Another thing we could do is talk about like document resolution and things like that, but we don't really have a way to test that other than just like taking a document and like going through all of its resolvers at the moment. I think being able to like load a document into the engine via like the
Yeah, the config file is the entry point anyway.
yeah, so I feel like that's a good place maybe to start. Um, Currently, Contentlayer uses ESBuild to take the Contentlayer config, uh, ESBuildify it, builds it with ESBuild, and then spits it out into that like .contentlayer directory, and then that config file is basically what's used to trigger like um, everything else that happens like with content layer. So that we could take the same approach. We could use ES build. We could use something else. Um, but I think the first step is essentially to figure out like how do we grab the config file and uh, compile it in such a way that we can then make use of it.
I mean,
Um,
ES build is a fairly used and common tool. I
yeah,
don't I don't really see any reason against using it, given it is a TypeScript file, unless we want content layer 5269, whatever we end up calling this, to work only on a specific runtime, such as ban, for example, that can directly load TypeScript files. We're gonna have to compile it
yeah.
anyway, which,
I think
sort of begs
starting
the
with
question: we can probably use ES build.
yeah, I think starting with ES build and like we can build out from there makes sense. Um, and I do have like the benefit of a tiny bit of like context in this because like at some point in the past I did try to take the existing like build pipeline for the config file and use like the more modern effect APIs to compile it. So we can maybe take some of those learnings with us as well. But I think maybe a good place to start is to um, basically make uh, an with the functionality that currently exists with content layer is the config file is watched for changes. When a change is detected in the config file, um, it rebuilds the config and then reloads all of the documents, which makes sense, right? If your config changes, if the config itself changes, you probably need to regenerate all the documents.
Yeah.
When we are working later on the actual like documents loading content, um, like we can obviously take uh, caching into consideration and like if a only rebuild the documents that have changed if you're actually editing the document. When you're editing the config file, I feel like it makes sense to reload the whole config. Um, and
And also, changing the config doesn't mean actually rebuilding everything down the road. You trigger a rebuild, but then it would be the engine that actually decides if to rebuild or not.
right, right. So I think the approach I had taken when I had done this previously was essentially to build like a ES build plugin with effect that hooks into the like what do we call it like the watch functionality of ES build for the config file. Um, so maybe we can start going down that path first and then see where it leads us.
Yeah, I think we need to define a type for the config though,
So let's
and probably a make.
Um, so let's make an ES build.ts, and then we can also make a big.ts, maybe. So let's start here.
And probably should call that make document, so that at least it doesn't conflict with make. Because I guess we're gonna have a function also for the config to make the config or not.
My idea is like the config is okay, wait. So let's actually it's good to iron this out first. Um, the config file, like imagine this is our content layer config, right? My idea would be like you'd be importing everything as document from that effect content document, right? And then you'd be doing like, export const post equals document dot make, blah, blah, blah. And similarly, maybe you have a blog post or a docs page, etc. Right? Um, so my idea is like the content layer config is basically just a module that exports a bunch of different documents.
Okay. So you also have then the like MDX configuration, so on and so forth per document.
Right, because we are if we look back at the document.ts for a moment, um, document.ts, the file system source is essentially what's going to like, this is essentially what's gonna determine in my mind, like, we could make all of we could put the config well, actually, that's a good point. If we have, like, different MDX plugins and things like that, we might want to be able to handle that as well from the config. We could, like, if we have
I mean,
global
it, one thing is if we have separated configs per document and we want to use the same plugins across the different things, we can just extract a variable. There's no there's no rocket science. We just extract a variable and that's it.
well, I'm thinking, like, you brought up a good point with, like, the MDX piece, right? Where, like, yes, these could both use, like, a file system source that has the same, like, source dot whatever and this oops.
No, or rather, the source is different because probably the folder is going to be different between the two.
Right.
But the remark plugins or rehype plugins entry could be extracted to a variable and just reused in different
Yeah,
places. I guess makes
yeah.
sense.
We could also even from the content layer config, we could make the default export from the config an object that takes, like, the global configuration if we wanted to. We could
Yeah,
also
if
make
it's typing that.
right, I mean, and then the other thing is, you may want to process like you brought up, you may wanna process, stuff differently. Like your docs pages, maybe you wanna run some plugins on, and then your blog post, maybe you wanna run other plugins on. So, um, we might need to, like, think about, where the specification for those plugins would live, right? Like, is it gonna live inside the source? Like, when you import a particular source, content source, right, and you create the source within your document, is one of the properties of the source, like if we say a file system, is one of the properties of the source besides paths going to be like, I don't know, right? And similarly, remark plugins, whatever. Like this is one strategy, and you could, since it's just a plain TypeScript file, like you said, Mike, you could have some plugins up here and a global variable and add to them, whatever. Um, like this is definitely one strategy um, for doing that, right?
And I think that's okay.
Yeah, I think when we start talking about like the content sources, we'll probably have another conversation about like these plugins and things like that. But this is kind of like the idea I had for the config is like you're basically just exporting a bunch of documents, and those
Makes sense.
documents should be self-contained enough to generate all the content from them.
Makes sense.
Cool. Um, oops. So So yeah, I think we can start thinking about these two things. I already have like an idea of what the ES build um, plugin would look like because, like I said, I've done it once before. Um, so we can take the benefit of like learnings, right? So I think one thing we know we're probably going to need is to install the ES build. I think I renamed this to Effect Content. I think let's find out. I think I can do this. Yeah. Okay. Um, so I think that it might be worthwhile for ES Build. to be a service, right? So I think whenever I'm like starting to create a service with effect, I usually like to just start with the make function. And then I also usually will do, if I know I'm creating a service, export class, let's call it CS build for now. Extends self.
You first need to, yes, build. I can't wait until the point where we have this type of make dot success,
Yeah, same.
and that's it.
Uh, this
Which, by
and
the way, we can only do that because we've made the environment covariant, quantum, and using a union. Because otherwise, we could not have field called context.
yeah. Sorry, I was only half paying attention for
Yeah, I was
thinking this.
taking a tangent.
Um, so when I did this before, um, when I did this before, I separated out the because ES build like as a package when you use it, it takes a whole bunch of build options when you're actually like running it. And I remember wanting to separate the build options from the actual plugin when I did this. So maybe it would be worthwhile to do that up front.
And
Uh,
by the way, just for the sake of it, given that we probably want to let the user use effect directly, we should probably specify effect as an external in the build of the config.
yeah, I think that content layer currently, I think the current implementation of the current content layer configuration, the ES build has a plugin that is specified internally that marks every package as external. Like,
I think it bundles effect.
I don't think it. I don't. I don't think it does, but it might. We can
Anyway,
actually.
that's
Yeah,
beyond.
it doesn't matter. We're rethinking this anyways. So, but let's let's go with let's let's say build options equals context. We don't really need. Uh, Actually, in this case, I think I can just use a generic tag. Um, no, I want to use the class. Um, no, I can use generic tag. And this is going to be yes, build options, I think is a type. And I'll say add effect content or I think cool. Um, so then in here we can grab our
Do we actually want to use a generic tag for that?
I don't know. Not sure yet. We could make it a class and then switch to a generic tag if it works.
Yeah, let's start making it a class. Sounds that's a better option. You can also make an effect tag so that you can directly access the methods if.
I need to add all my snippets back to NeoVim that I had in VS Code where I could create these snippets. Effect. No, this is esbuild.build options. Layer dot. I'm not sure we want to specify that yet, so we'll just leave it like this.
And oh, change also the tag ID, otherwise it's gonna conflict.
Yeah, I will do that. Options. Options. So now we should have the ability to, yeah, get all the ES build options. So in here, we need to do a few things. We need, since this is going to be a watch plugin, right? This is basically going to be an ES build plugin that we add that watches the content layer config and rebuilds on changes. And we probably want the ability to um, consume those updates independent of ES build. So what we might want, uh,
Also, one other thing, how do we want to expose the final process? Do we want to have like a CLI?
I think
Uh,
a CLI, and that was the way I was imagining it. Like when I had been working on this previously, just like for fun, I had imagined that it was a CLI that was built with Effect CLI that we could then like basically utilize to trigger the various like stuff within content layer. For example, I could imagine a situation where like you want to test out some stuff, but you don't want to actually build your content, right? So with the CLI, we could expose additional like functionality. For example, imagine you want to like generate the types for your content layer documents, but you don't want to rebuild the content. Like we could expose all that functionality through the CLI. So that was kind of like the thought process I had. It's like we have a CLI that allows you to do this. Yeah. What do you think?
no, I tend to agree. I know Contentlayer also has like plugins for Next.js and other stuff, but
I think we
um,
can get, if we want to, we can get there, but like I think that I think my idea is like the main entry point to content layer that we should be focusing on for the moment would be just the CLI, and then we can
yeah.
always like if we build the core separate from the CLI, right? If like core is a package and CLI is a package, and then like we can figure out ways to make that experience a little bit nicer. But if we separate core from CLI and we just, make core a dependency of CLI, then
Well,
we can
CLI dependency of no core dependency of CLI.
then basically like people could install the content layer CLI or they can install plugins for Next or Astro or whatever. Like we can build those down the line, but as long as the engine itself is separated, then like the entry point to the engine we could build like separately as long as we make it flexible enough. All right, so I am going to make this a queue. I think his build has like a yeah. So there's a build result type, but but I remember I remember. Uh, so when doing this, when we have like this watch plugin running, we're going to basically take the results from the watch plugin and we're going to put them in a queue that we can then consume from effect, right? And um, what we're actually going to want is the ability to both have access to successful ES build results, but we're also going to want the ability to have access to build failures, which we can then like render in a helpful way, especially if we're running like the content layer CLI in watch mode or something. When you
Yeah,
when
you
you
change
get
a
it
config, you make a mistake, you see an error.
exactly
Yeah.
So maybe what we can do here is just leave this empty for a sec, and maybe we can have like an ES build result type, which can be exit or either. Um, let's start with exit, maybe.
I mean, exit might also have more cases, like it can represent a defect. So it's gonna be very hard if you then have to match between just the two.
I'm wondering, like, do we want the ability to have the full cause that we can render?
But if it's the build output, I don't think you have a cause in the first place.
So maybe then we'll start with either. So we have on the right side, we have a build result from ES build. And on the left side, we have some ES build error type, which we'll stub out for a moment. So, and we're going to want to have a queue of this. Because the idea is, yeah, the plugin is plugged into ES build, but we want access to everything that's coming out of the plugin in effect land. So we're going to basically allow like pulling from the queue in effect while the plugin is still plugged into ES build. Um, so let's create the plugin. I think ES build has like a plugin interface. And the name and a setup method. Name. I think actually it has to be like a setup. We get a build, I guess. Right. Okay. It's all coming back. Sort of. Okay, so what we want here is we want to do something when the build ends, right? And we get our result. And no, this is wrong.
What's that syntax?
I don't know.
That was a Scala.
Yeah, this is okay. Now we have build.
Like I would love to have that syntax, to be honest.
um. Okay, so when we get the result, we get errors. We also can get a successful result. So I think we're gonna want like all of these properties in the output. But what we can do is like if result dot we have again errors is dot lang. Maybe we use array from effect. Array. Come on.
Yeah, proper ID would have known how to import this.
All right. Relax. Is non-empty array. Result dot errors. Okay. So let me just shut off those diagnostics.
Like it would be very funny if I end up using NeoVim at the end.
It would be I yeah, that that would be fantastic. I can't ever actually see it happening, but yes, that would be amazing. Um, okay, so if we have a successful results, we can do a queue. I think we just plop the result right in there. Um, and if we have errors, uh, I guess this is a situation where we're going to want to start. Um, so I guess errors is an array of messages. Okay. So queue dot unsafe buffer results. Maybe we'll
So
just
what are we doing? That's a good question. We're reinventing uh, content layer, which is kind of I don't know utility. I would call it a framework independent utility to build content for um, content projects such as Next.js and so on and so forth. That was initially built using Effect and ended up being unmaintained. And while using it, we've realized that there are potential some potential things we want to improve, and on the other side, we don't really need all the featuring. So we are seeing if we can build something from scratch which resembles the user experience of content layer, but that is purpose built for our usage, and that it is much more parallel than the initial version of content layer to make building content extremely fast. And we don't know if we're gonna get there or not, but we're positive.
yeah. Plus, we also thought it would be a good experience. We also thought it would be a good experience to try to build something in public, and show folks like kind of the maybe like the process that we use to approach some of these packages and like what we focus on, what we don't.
And dog food a little bit on the various ecosystem libraries that we've built since.
Option public and tolerant. I think this could be yeah. Okay. So what I want to do now,
Okay, so basically you're just adding a new plugin into to the S build pipe.
yeah,
Got it.
and now we're gonna essentially like so we can specify like the build options separately, which is nice. Like this is the thing that's actually going to run the ES build context. And it's basically just going to expose to us a queue of results. So actually, we can even do that right now. We can. I think that we only need to expose the results. We can change this, but I think why is it not happy? What do I do? Uh, this let's see. Extends clause. All right. Well, we'll see.
Hazard. That's a TypeScript thing.
It's because I wasn't returning an object, and it's effect.tag, so it needs to be an object.
Yeah, that's true.
So, okay.
Well, I mean, it doesn't need to be an object, but otherwise, I think you need to like re-export a queue. I don't know. I mean, it is an object. A queue is an object, so you should be able to just return the results.
Yeah. So okay. So what I think esbuild dot watch no esbuild dot I think we have to create, if I'm remembering the esbuild API, I think we have to do something like esbuild dot context, right? Yes, because this thing, like, this is the advanced long running form of build that supports additional features such as watch mode and a local development server. Yes, this is the thing. Okay, so this is the
Like,
thing.
works in Node, yes. Works in browser, no.
Okay, so first we want to create a context, and then we want to watch that context. So, and I'm pretty sure this is resourceful because I think you can actually close a context. So let's do,
And by the way, it's already an interesting question to inspect if we should use yes build for watching or the effect platform watcher and just invoke yes build on changes. That's
yeah, I mean, I think it's definitely an interesting question, because we could do that with this. I think that we're going to end up having, I mean, we're going to have a separate file watcher anyways that's watching like the actual like document content itself. Um, I don't know. I feel like maybe we start with ES build here, and then if we're unsatisfied, we can always like we can easily change this service to swap out the implementation for a effect file watcher.
and also I need to check if the file watcher from effect is recursive because I remember an issue created the repository that it might not be recursive,
I don't think we support recursive yet.
which will be a problem for this. Like not for watching a single thing, but to watch the actual content.
So here we take in build options, and we actually want to modify the plugins because we've modified the plugins. So if we do this, that'll work. And then I think we want to do a pipe backup, and then watch. I don't think we need to pass in the options here because don't think we need any of them. Oh, there, it's an empty object. Anyways, great. And then, oh, actually, we want to tap this because here we want context. I think there's like a context.dispose. Yes. Is this a return a promise? Yes.
And probably also the watch should be inside that is a promise too.
Indeed. And we should decide like if we want these to be defects or not, because right now we're elevating everything to a defect.
Yeah, I mean, I think if you don't find the config, well, arguable.
I import using import type. I did. So now, okay, so if we walk through like what we've done here,
Does the
uh,
watch just start the watch, or or does the watch wait, or I don't know.
I think that it Let me look.
And also, by the way, this is a very, like, we are acquiring one resource, and in the acquisition stage, we are doing another thing. So if the watch fails, we end up leaking a resource because we
Yeah,
don't
maybe,
close the context.
so maybe here we should just be acquiring the context and then watching as
Yeah,
a separate step.
that was my point.
That's a very good point. So let's.
I mean, it's an edge case, so
Oh,
by no means this probably it's never gonna happen, but
it's still a good thing to guard against if we can, which we can, right? So, and this thing now,
I mean, it looks even cleaner.
yeah, and we do we want to fork scope to this? Do we need to? No, because watch. I don't think this is going to block, and I'm pretty sure. I'll look at the documentation really quick. Um, is build API watch. I know that you guys can't see my screen. I'm sorry. Um, I'm pretty sure that watch. By the way, I'm reading the documentation for watch, and it does say that it is possible to implement watch mode yourself using ESBuild's rebuild API and a file watcher library of your choice. Um, so just something for us to keep in mind. But I'm pretty sure watch runs when you call it. Um, and then we'll watch the file system for changes. We can double check, but okay. So now we have an ESBuild plugin that we've created, and we basically patch the plugins that we pass in from the options. And what we're doing here is when the build ends, we're checking if there were any build errors, and if there were, we're creating an ESBuild error and passing it to our queue. Similarly, if there were no errors, we create a successful result and pass that to the queue. And now we get access to the queue in the interface of our service. So we basically now have ESBuild running as a watcher for the Contentlayer config, passing all of its results to an effect queue, and then we can use that queue to basically do stuff. And one of the ideas that I had, and I think Tim had helped me implement this when we were rethinking Contentlayer at some point in the past, was in effect, we have a little known type called reloadable. And I thought it would be cool to basically have um, this this plugin that we're adding essentially does, you know, watches the content layer config eventually and puts its results into the queue. I thought it would be really cool to basically have another service that's constantly watching that queue somehow and uses reloadable to reload a service inside the environment that actually has the resolved configuration. And we had to figure out a way to do that a while back. I just have to remind myself how we did that.
Probably using reloadable.
It was using reloadable, but I just I might have to pull up like that old code and look at it while we do this. Um, but yeah, so this should already give us the ability to pass in build options from the outside and watch a content layer config. Are there any errors here? No, we're good. So in config, we sort of need to decide what config looks like now, I think. I sort of think that the when we load a content layer configuration, right? If we think the config file is basically just a file that exports all of our documents, a resolved content layer configuration could just be an array of documents that we've loaded from the content layer config at its like simplest, right? Um,
Yeah, I mean, we're gonna get uh, an ES module, so we're gonna have to import that in some way and then loop through the exports.
right. So,
Which, by the way, makes another interesting point. We probably need to add a digest to make sure that two subsequent builds of the config don't end up with the same
yeah.
file. Otherwise, we when we import, we're gonna have something cached.
Well, the nice thing is that the content layer, uh, I mean, the ES build, um, like when the options, you have the ability to specify like a hash, like like you can put, I think it's like entry names or something like that is the name of the build option, but you can specify that the file name that's output should include a hash, and so that kind of like automatically guards against um, like what
What
you were
I'm
saying.
thinking about is though how do we guard against memory leaks? Because if we're keeping importing modules, they remain imported for eternity.
Mm.
Probably need a sandbox and to import the stuff inside a sandbox.
Yeah, that'll be an interesting thing to look into. Hmm. Well, for the moment, um,
Or are they?
well,
That's such an interesting point.
yeah, kind of something interesting to think about. Um,
Do dynamic imports assigned to variables clean up if those variables are cleaned up? That's-
so okay, so let's think about the config for a second. Let me look at all my old code for a minute. Right. We had a concept of like a config loader service, and then we had a concept of like a config watch. So let's think about this for a second. So um when we get the ES build result, we're gonna want to take that result. We're gonna want to do some stuff with that result, and eventually we're probably gonna want the array of loaded documents. We're also probably gonna want the hash because the ES build, not like the hash, like the ES build hash that's generated, because we could probably use that for some degree of caching as well. Um, but for now, maybe we can say let's try this. Um, we want our ES build service, and we want to we basically, so to build a config, we might want to have, okay, let's try this. Const So, oops. Okay. So this gives us a queue of ES build results. We're probably going to want to be taking from this queue and we're probably going to want to do something with the results, like build the actual configuration. So let's just declare a stub that takes in a result, which is a yes build result. Um, we're probably going to want to do this in background fiber because what I'm thinking is um, we can have another, basically an intermediary queue here that's taking everything from the queue of results that ES Build's giving us, building the configuration, putting that result into a queue, which we can then expose. And then we essentially have a service here that is um, constantly reading the updated build configurations and giving us a queue of configuration results, and we can potentially I'm not sure if like the intermediary queue makes sense, but we can basically reload this service. We can basically reload this service anytime the anytime the um, configuration changes. So this way we don't have to reload ES build every time, right? We don't want to have to restart ES build every single time. Shut it down, restart it. We'd like ES build to keep running. We can reload this service, which is taking from the ES build queue and giving us configuration results. I'm not sure if Q is the correct way to go here, but humor me for a minute. Okay. I'm just sketching out like what I'm thinking here, and then you can tell me if it makes any sense and how we can adjust this. But this is like the effect content or um, config success make. Now here is where I think we can do something interesting. We could um, first we can have a static layer live, which is a layer dot scoped layer dot scoped this make, which we can then do a layer dot divide. Uh, right? And then we can also have a menu, I think. Yeah, we're going to reload this manually, not on a schedule. And then the layer. And then, okay. And then thing, reload. Getting unknown. Um, okay. No, okay. It's not what I want. Whatever. Okay. I don't know why reload has unknown in the error channel. There's got to be a reason. Um, so anyways, the idea here would be that, like imagine like uh, we're in the CLI and we can like use effect CLIs like, there's provide commands to the CLI where you can do like command provide. You can use the options and arguments from the CLI to actually inject context into the command handlers. You could do like config.reload or not reload. What did I do? You could export a function. Oops.
Not so sure I understand what we are doing, to be honest.
It's okay. You might in a second, and if you don't, then we can just abandon this. But I had written something similar to this in the past with Tim. Basically, the idea here now, and this watch method would be something that we could use in like a command handler in the CLI to watch, like for example, in the watch mode for the CLI, where we have like fs seals. Hang on. Actually, what are we doing? Where we
Like the above does not reload the config, reproduces a queue of configs.
Yeah, I have to think about this more. I forget exactly what we did. It was something like we we used the reload method here whenever the content layer config file that was specified on the CLI changed, and then we created a stream where we like used this get method to get the config results. But I can't. Yeah, I have to remember exactly what we did. But the idea would be to use reloadable somehow to avoid reloading ESBuild, but reload the config in the environment whenever the
Which this does not, because you're providing ESBuild to live, and the whole live is provided to reloadable.
right,
So this will reload ESBuild.
right. Um, yeah, I have to think about this more, but that's kind of like the idea. Um, yeah. Anyway, I am almost at time for myself,
Yeah.
but I do feel like we made really good progress today on the document. I'm really happy that that API came together very nicely.
And I was also searching if we can unload a module from memory, and the answer is no. So
That's great.
we need to see how.
Yeah, we're gonna have to figure that out. That's gonna be an interesting problem. I bet you that is. I don't know if Contentlayer currently solves that. So
No.
maybe that's why, especially in local development, maybe that's why things start to degrade quickly.
Yeah, well, I mean, there are ways of creating isolated VMs. So the idea would be to create an isolated VM and let it run, but that also means that we have to pick a runner, because I'm not sure that the isolated VM runs in ban, in node, in but I don't think that's a huge deal, because we could say that, yeah, our content thing works in Node.js for the watch, and everything else you can consume the output from wherever you want. So that might not be a big deal, but an interesting thing to explore.
Yeah, I might hack a little bit on this off stream again, and then obviously like we can. I'll let you guys know like if any changes are made. But Yeah, it's kind of there's a ton of interesting problems I feel like that will come up as we're going through this. The module loading obviously being one, but yeah, cool.
Good.
Well,
Cool.
thank you everybody for being here. Hope you guys enjoyed the stream. We started to actually get into some like effect code. At least we built an ES build watch plugin. Um, so yeah, hope everybody enjoyed it, and we'll see you next time.
See you, folks. Thanks, Mats.